So we're going to talk about developing a problem solving within a mathematically literate environment. And what I'm going to do now is, I know that problem solving has been a focus for quite some time in math classrooms, but I think why we are still seeing questions, concerns surrounding students and problem solving is that we're not quite going deep enough into the instruction and into student learning. So what I'm going to kind of share today is a framework that we can do that, and I'm going to share some specific strategies about how to bring that out in the classroom. So let's begin. This is Who Am I? Melina already talked about this. And this is a problem I've given a bit. If you're familiar with it, you can just think about some of the strategies you used. But I want you to kind of work through this. So it's called Find the Fake. You are given 8 coins and told one of them is a counterfeit coin. Uh-oh, seems criminal. The counterfeit coin is slightly heavier than the other 7 coins. Otherwise, the coins look identical. So they look identical. It's just that the counterfeit is slightly heavier. Using a simple balance scale, how can you determine which coin is counterfeit using the scale only twice? So you can only use the scale 2 times. How can you determine which coin is counterfeit? And I'll give you a few minutes to think about this, because I think it's important that we engage in mathematical thinking, and it kind of puts us into perspective of what our students are and how they're feeling in the classroom. So when you're thinking about this, I want you to think about these 3 questions that I just put up on the screen in red font. Do you need to know what the answer is for this question, and why? Is this something that you feel that you need to know what the solution is before you can move on? Do I need to share the answer or provide an opportunity for someone to share the answer with everyone, and why? And what do those 2 questions imply? So who here would need to know what the solution is for a problem if they were assigned one in the classroom? Who would need to know what the solution to the task is if they're given one?
There are some me's in the chat.
Some me's, okay.
There's one me in the chat, I should say.
Okay. And the question is, if people wouldn't mind sharing, why do they need to know what the answer is? And to tag along with that, do you think if I gave this task or question to a class, do I need to provide time to discuss what the solution is, either with me discussing it or with asking a student to discuss it? Do we need to have that? Do we need to make time for that?
The response to the why was curiosity. Someone else said, I can help students figure out the solution, was the reason they chose me.
Okay. And do we need to provide an opportunity in the class to review what the solution is, either through the teacher or through student sharing?
I need to have tried to solve it myself so I can think through possible solution strategies.
Okay. No, and this is great, because it makes perfect sense to have experience with the task, with the question, so that you can kind of identify what are some pathways students may take and what are some misconceptions that may arise from this. When I give this problem to students and to adults, depending on the time of the session or the time that I have with them, I don't always provide the opportunity for people to share what their response is. Instead, just like when we give an assignment that involves a writing, we always have that individual or 2 lesson goals or our learning goals for the students. And for this particular task question, what my goal isn't to see who can solve the problem. It's to see who can work through some of the stumbling blocks. My goal is to see, what do you do when you try something and it didn't work? Too many of my students and too many people I see who engage with a mathematical task or really any task, when they try that plan A and when plan A doesn't work, they will shut down. They will just wait it out. And instead, as problem solvers, we need to be cognizant of, sometimes, most times, plan A may not work. So what do we do next? That's what I want to see. That's what I'm going to focus the conversation on if I give this to my class or if I give this to adults. What did you do when plan A didn't work? So is there anyone willing to share, did your first attempt not work? Did your first attempt not reach a solution? And did you try plan B?
I might invite folks to come on with their mic if they want to state this. I just feel like it could be a lot to write.
Yes.
We do have first attempt would only work if I had more than 2 weighings, was one response.
That's it. So did that person try a second attempt, a second strategy?
I see Jean with their mic on.
Yeah, so I was going to say the same thing. I figured out that with only 2 attempts, it would only bring me down to 2 coins. So, and then I wouldn't be able to use the scale to tell which was which. So my plan B was just to see if I could figure out then, without using the scale, if one was heavier than the other. But I don't know that I would get like a true answer.
True answer. No, this is great. Thank you for sharing, Jean. Yeah, and it's one of those things that, think about your own classroom or the students you work with. Do you have some students who, when they try that plan A, do they just shut down if it doesn't work? Instead, what I would love to see students do is, if they try plan A and if it doesn't work, take the learning from that experience and use that to make an informed plan B. And I don't see that as much in math class. So those are some of the things that we're going to talk about today. And the strategies I'm sharing is from this great book. I hear amazing things about the book and even better things about the person that wrote the book. Here, he's a really good guy. So that's where the strategies are coming from. And then the question that I get sometimes is, well, why do you view math as a literacy? And here is kind of the rationale for the work. What I've seen in language arts classrooms, I've seen students who are self-monitoring. When they're reading, if they're reading something and if it doesn't make sense, they'll stop and they'll go back and they'll either reread the section, they'll skip ahead to see if those comprehension pieces come together and it makes sense, or they'll try to use one of the other reading strategies. So they're self-monitoring and they're monitoring when they're coming off the tracks. They're focusing on communication and on meaning making, both as expressing themselves and their ideas and in receiving and understanding what is being said and making meaning with that. What I see in the math class, I see a lot of self-doubt. Think about your class, regardless of what grade you teach. When a student completes a question or completes a task, how many times do they rely on the teacher or on others to tell them if they're correct or not? They'll come up and this is common when we give a test. They'll come up and they'll say, well, I'm not sure how I did. And you're thinking at that time, you could really teach the class for me if I'm not there. That there'd be no doubt whatsoever that you would have understood these concepts. But there's so much self-doubt that they rely on the teacher to be the determiner of if they're correct or not. And I see a lot of a surface level. We tend to spend a lot of time on going 1 mile wide and 1 inch deep, instead of flipping that and going 1 inch wide and 1 mile deep. Think about it this way. I've never had a teacher come up to me and saying, David, you know, I've got about 30 minutes of my day that I'm not quite sure what to do with. Is there anything extra I can do? No. and I see teachers who are running the risk of burning out because they're crafting all these centers, games, tasks, questions, that they're only getting a few little interactions out, and then they feel the need that they have to go on further and have to craft additional things. And I think we can dig down beyond that to get that greater value added for that. So that's why I see the work is I see some of the strengths that we can bring into the math classroom that we see in the literacy realm. And when I'm talking about a literate environment, I think of three spaces: instructional, thinking, and physical. And the sweet spot is where they intersect. And that's where we get the longevity from. That's where we get the sustainable student achievement. And that's where we get something that we can do it in a manageable way. So we're going to kind of look at these three spaces from the perspective of problem solving, with the first space being the instructional space. And what I mean by the instructional space, it examines teachers in instructional decision making. And how do we approach the lesson? And a way that I think of this is, as a teacher, when you're planning, that we have the thoughts in mind of what does success look like? What does success in terms of student understanding look like? And I like to add this next part. What does success sound like in the classroom? How do students communicate and share and talk about and demonstrate this understanding through discourse? And the lesson plays a large part in determining how students engage with the concepts, such as the choice of the problems, whether they work individually or with others, and what counts as successful completion. But how you craft the lesson also reveals to students what does a quote unquote, if you can see my hands, what does a good mathematician look like? And that's what comes out from your planning. So we're going to talk about problem solving, and this whole session is framed around problem solving. And I want to stress this. Problem solving is a verb. It's a process. It's something we do. And I think too often we get away from that and we think problem solving is something we give. And we think, oh, well, I found this great, quote unquote, problem solving questions. But what I'm going to kind of push back in is that problem solving questions don't necessarily exist. While a question may engage some students in a problem solving process, it may be practice for others. So some of these questions that we find that are touted as being problem solving questions, it might just be practice for some students. Have you ever used some of these questions in the classroom thinking, oh, this will be great, this is a problem solving question, only to have students in 1 to 2 minutes raise their hand saying, well, I am finished. And we tend to say, oh, can you show me it in another way? Well, that's not so much a meaningful experience. What that can be is a way to just to kind of buy us some time. So I want you to think about that. Problem solving as a process, as a verb instead of a noun. While graphic organizers are great, they're not necessarily something that will make students into a problem solver. Graphic organizers can be used strategically, but if we rely too heavily on them, they become a crutch, and students aren't problem solving so much as they're just using one specific tool to help them. And we don't want that. We want students to be flexible. We want students to use different things. So my question is, instead of this and finding, quote unquote, the problem solving questions, why aren't we focusing on instructing and supporting students' learning strategies? So here's one type of strategy. Strategy one. It's a toolbox. So problem solving is not about following a specific strategy. Instead, students can generate strategies and or rely on strategies that they have experienced both inside and outside of school. So a strategy toolbox provides students with options as they encounter problems. So when I think of a strategy toolbox, I think of what we think about in terms of a mental math. We're not mandating every strategy, but there's strategies there that students can select from when it's appropriate and when it's effective, and they can use them flexibly and interchangeably. That's what we want to see in problem solving as a strategy toolbox. So not all students need to master every strategy. Instead, students will gravitate towards the strategies that they understand, that they have used, or that they see benefit of using. So these strategies can be applied flexibly by students as they encounter problems. So here is just a snippet of the strategies that I talk about in the book that some of us are already familiar with. Paraphrasing the problem. I think it's crucial if you give a question to students or a task or a center, have them rephrase it in their own words to check for understanding. Do they understand the problem? When you look through these strategies, and I'm going to pause for some questions, what do you think of the strategy toolbox?
As much as I think I am teaching problem solving, I still rely on finding problems and focusing on computation. This toolkit is a great reminder of that difference. It's one of the comments.
Perfect. And while it's still important to have quality questions, I just want us to kind of think about, are we supporting students in becoming problem solvers? And I'm going to go to the next few slides, but Lena, if you want to interrupt me at any time, go right ahead with some comments. So this is a strategy toolbox from Teacher's Voice, and these are all snippets from my book. So before these problem-solving strategies were shared with me, I'd often focus on having students reread the problem numerous times as a way to work through the stumbling block. I thought if they read it enough, they'd be able to understand. However, this doesn't necessarily work. Since I've worked with students on these strategies, students now have a toolbox of strategies to apply to solve the problem. I can have conversations with students about the strategies instead of directing them to reread the problem. The conversation turns to strategies as opposed to rereading. So that is shifting what our conversations are with our students into the a thinking and a learning instead of what the specific question. And here is it from the student's voice, and I love this a comment. So we get a lot of problems that have decimals. We've been learning about decimals for a while, but I find it hard. I have to figure out what to do to solve the problem, and I have to use numbers with decimals to find the answer. So I have used the solve a simpler problem strategy to help me. I change the decimals to small whole numbers, and then I think about a plan to solve the problem and do it with these small numbers. If the answer makes sense based on the small whole numbers, I know that I've chosen the right plan, and I redo the operation with the decimals. If the answer doesn't make sense, I know I have a calculation problem and I need to recheck my work. The solve a simpler problem lets me figure out the right plan without getting overwhelmed with the decimals. So like, wow, that is awesome. Right there. And then when we're thinking about the problem-solving process, I go to the work of Apollia, and I'm thinking 1945, and it's still quality work. And if it's 75 years old, it's still good. So there's really four steps or four components. Understand the problem, craft a plan, carry out the plan, and review. So this is one of the anchor charts that I've used in my classroom before. But the students and I spent quite a bit of time on looking through these processes, but we highlight how people tend to think this is a linear process. You go from step 1 to step 2, such as this, but it's really not. And I couldn't find enough arrows to do. But we start to see something like this, and I'm going to kind of do it in even a more pronounced way. It's often a cyclical flow in that we can go back and forth to these parts, and then because it is it is quite a fluid process in that we can understand the problem. We can go to craft a plan, But then when we're working through craft a plan, we can think, okay, do I clearly understand that? And I can go back to understanding the problem. Or I can take that plan and I can carry it out into that third component. But then if that plan isn't making progress, I can either go back to craft a plan or I can go back to understanding the problem. Yes, sorry, go ahead.
I just have Eric mentioned, I agree about being a flexible problem solver. Problem solving needs to be more than students memorizing a list of problem solving steps.
Yes. And then what they need to be able to do is they need to be able to think about problem solving as a verb and to work through this fluidly and to know and to have some strategies that'll support them in crafting a plan. And if I was a visual tech person, I could have this much more fluid, but a large conversation I've had with my classes is it's just not going through like that graphic organizer, step 1, step 2, step 3. But it's a fluid process that we can go from understanding the problem to crafting a plan, and then we can go back to understanding the problem. And then we can go to craft a plan, carry out the plan. And I've known that I've showed them work before when I'm all the way down at reviewing, and I have to go all the way back to understanding the problem just to see if that's making sense or if I missed something. So it's a fluid process that they have to be comfortable with. And the one way that I've stressed this with them is I showed them some of my own work samples from this, and I've asked students to share their work samples with me so that we could share it with the class, so that we could have that discussion as a group saying, look at how this is an ebb and flow, and we can kind of go back and forth throughout this to make meaning. And this tweet really kind of summed it up for me into, it's just not about which strategy did you choose. That's not going deep enough. We need to go beyond the surface level and ask why that strategy. How did you know that strategy would work? And then what would you have done if that strategy didn't work? And one of the things that I think that we need to do more of, if a strategy isn't working for a student or if it's not leading them to the solution, is still a valuable experience, because we can glean from that certain understandings and certain aha moments that can help us make an informed decision for the next strategy. It's like when I hear some people say guess and check is not an effective strategy. Yes, it is an effective strategy, so long as you're using that to actually narrow in on a solution or narrowing in your plan to work towards what that making meaning and solving it is. So next we get, so then that was the instructional space, and it's from the perspective of the teacher. Well, now let's think about it in the thinking space from the perspective of the student. And what we have here is it's a perspective that involves more than how students solve or complete a task. We want to go beyond that. The thinking space involves how students approach the problem, how they frame their thinking, how they support this thinking, and how they navigate the problem to conclusion. So an example of this that we can use in a problem-solving realm is an eraser strategy. Is an eraser-free strategy. So I know accuracy has a place in math. Completely get that. When I go to the doctor or when I go to a pharmacist, I don't want them guessing, yeah, this looks about close enough to 50 milligrams. Let's just go with this. Yeah, no, I want accuracy. However, I think that we need to highlight and emphasize the process as well. So the answer or the product is still important, but when the answer is considered in isolation from thinking, it's deceptive. Looking only at the answer, teachers may not understand how students navigated the problem to arrive at this response. If we're interested in mathematical understanding and using student learning as the compass for instruction, we need to explore student thinking in the process. And what I have for you is an example here. If you have a piece of paper next to you or a tablet or whatnot, I have 9 numbers: 1, 2, 3, 6, 1/6, 1/3, 1/2, 2/3, 3/2. And write that, and your goal is to put those 9 numbers into a square 3x3 grid so that each number occupies 1 square, and the product of every row, of every column, and of every diagonal is equal to 1. And the purpose being, what I would like you to do is, as you work through this task, please do not erase any of your thinking. Instead, you can cross out the items, you can record aha moments, stuck moments, or any changes in your approach. So I'd like you to do that. And when I'm thinking of an eraser-free strategy, sometimes I'll have students use pens so they can't erase their work. Sometimes I'll give students chart paper and I'll give them a marker so they do their work. Because think of what we do when we have students write a text for us. Very rarely do we just want to see what the final copy or the published copy is. We want to see their draft. We want to see how they revised it. We want to see how they edit it, because that's where their thinking comes from. That's where their thinking is. That's where we learn how they approach this piece. But in math, when we let students always use an eraser, we're really missing some of what their thinking is, and we're just looking at the answer in isolation from their thinking. So I'm going to give you another minute to do that. Now, if this was more time, I would give you more time, but I have to work within the hour time slot.
Just to add on, while everyone's working, Eric shared the book Powerful Problem Solving by Max Reek. Has a great visual how fluid actual mathematicians are in their problem solving process compared to typical students, on page 154.
Yeah. And it's that fluidity that's important. Okay. So we're just going to move on, but I want you to think about, when you were doing that, as soon as you do not erase your thinking, it provides the teacher with a great source of assessment info, but as well, it provides the students with a documentation of their learning, and that they can use that to build their meaning making and work towards that solution. And here is an example of a work sample, and I'll just read what the word problem is. So Dana wants to buy 2 new video games. Together, the cost for both games, including taxes, will be $95.43. She babysits for 3 different families. Dana charges $8.45 per hour when babysitting. Wow, do you know what? Having children, I think it should be worth more than $8.45, but that's just me. If Dana has worked for 8 hours, does she have enough money to buy her 2 video games? So look at this work right here. And what we have is, at first, what Dana did was $8.45 multiplied by 3. And then she put not enough money, because she's comparing the $25.35 to $95.43. But what Dana did is she multiplied the hourly rate by the number of families, which is not the problem. So Dana said, no, doesn't make sense after she reread the problem. So she went to the next step. She said, okay, there's 3 families, which she took from the problem, and there's 8 hours that of babysitting. So that would be 24 hours. So she multiplied $8.45, her hourly rate, by 24, and she found the product of $202.80. She said, yeah, she has enough money. And then when she reread the problem, she thought, no, she didn't work for 24 hours. She has only worked for 8 hours. that the 3 hours is really extraneous information. So what she did is now she multiplied $8.45 multiplied by 8, and she had $67.60. And she said, no, Dana does not have enough money. Now, think about this. If we encourage, or if Dana erased all of the work on the left side of this, think of we didn't have that, we would not know what her thinking was through the problem, and we wouldn't see all of the different thinking points within that. Think of how much we would miss. And I'm not saying that we have to do eraser-free strategy all the time, but what I'm suggesting is look at what we're missing when we're having students erase all of their thinking. And look at all this problem solving that we're missing as a teacher when we're observing and assessing Dana's work. So here is a voice from the teacher. So this was a strategy that I had to give lots of thought to. In math, it's been drilled into me to use pencil and to erase any mistakes. It wasn't until I thought about student writing that the eraser-free strategy made sense. When students work on writing, they go through drafts, revisions, edits, but in math, we tend to go right to the good copy. The eraser-free strategy aligned with the growth mindset in that students could see how they progress through the problem and that mistakes can lead them towards the solution. Also, it let me see student thinking in a much more comprehensive way. And then from a student perspective, the student didn't like it at first at all. I was used to erasing my mistakes before passing it in, sharing with students, or putting my scribbler away. And why this student said that is they thought to be considered a good mathematician that you had to get it correct on the first attempt. But when I had to use a marker when working on the problem, I couldn't erase the work. I didn't like that I had scratched over my mistakes, but I saw everyone in class had the mistakes on their page. Everyone tried something, but then changed to something else. It's kind of like growth mindset, which a teacher and a school was working on. Now I don't care if other people see my work with mistakes scratched out, because learning can be messy, and how valuable that is. So we talked about the problem-solving strategy toolbox from the perspective of the teacher, and we talked about from the perspective of the student, the eraser-free. And what I also want to talk about is self-questioning. And I went through this with the session I did yesterday. We want students to be self-questioning as they're engaged with the problem-solving process. That's how they work through stumbling blocks. And it's a great metacognition in that they're thinking about their thinking, and they're being active learning within this problem-solving process, instead of relying on the teacher to give them hints about what they need to think about next, or how to work through that stumbling block. And here is one type of anchor chart that we use for the self-questioning. When students have these feelings or emotions, I don't know where to start, this isn't working, this doesn't make sense, I need more information, I'm unsure of how to proceed, or I think I've finished. When they have the I don't know where to start, these are some of the questions they can ask themselves to help them work through that stumbling block, or to go to the next step. And I think that we need to encourage and support students in being self-questioners when they're problem solving, because when they're always coming up to us and saying, I don't know what to do next, or I can't do this, we need them to frame it in a question so that they know what question they need answered to move to the next step. And another strategy with the self-questioning is a bookmark. And my class called this the problem-solving bookmark. And it serves two purposes. Questions and sentences provide supports for students in asking themselves questions during the problem solving, and it provides the students an opportunity to leave the problem and then to return to it at a later time. Students can use the bookmark questions as a way to re-enter the problem. Think about it when you're reading a book. How many times do we sit down and read a novel or a larger book in one sitting. No, we tend to read some of it, and then something tends to come up, and we have to leave it only to re-enter it at a later time. And think about all the strategies that involves. When you leave the book and you have to come back to it, when you're coming back to it, you have to kind of go back to your previous experience with the book. You have to try to recall what was going on, where you left out, and that leads you with some predictions of what may come next. And you really have to hit the ground running when you start reading from where you left off. Wouldn't it be great to do that with students as problem solvers? And here would be an example of the self-questioning of a bookmark. And you can see that we have it in the 3 problem-solving phases, the entry phase, the during, and the review phase. And you'll see that there's some different fonts because students, when I have this bookmark, I leave spaces because the original ones were the questions that we generated as a class. But then students can record their own questions, their own kind of self-questioning that they find helpful themselves within that. And what I'd like you to think about is when we return to school, instead of giving a task or a question at the beginning of class, give one at the end of class with only about 4 to 5 minutes left, with the purpose being we want students to realize that we don't always have to finish a problem in one sitting, that we can always leave it and come back to it, because that's what good mathematicians and problem solvers do. They'll work on something, then they will put it down only to come back to it at a later time. And coming back to it at a later time, we have these different perspectives of it, and we might have a new lens to look at it from. Any thoughts on that?
I was just saying that I really like that that you co-constructed the questions for this bookmark with the students and then left space there for the students to add their own questions if they had additions later on.
Yeah, just because I think there's much more value in supporting students developing their own questions, because otherwise, if it's always coming from the teacher, then how intrinsic is it going to be? And developing your own questions and being a self-questioner is a skill set that I think that we need to support students with and facilitate that with. Okay, and I apologize for talking so much. I just know with our time frame, there's a few things that I want to kind of share with you. So if at any point you're wanting to say, David, just kind of stop us so we can digest this, you are never going to hurt my feelings whatsoever. And the last space, so we went through the instructional space from the perspective of the teacher. We went through the thinking space from the perspective of the student in relation to problem solving. Now we're going to get into the physical space. Excuse me. So the physical space examines the arrangement of the classroom and how it contributes to a literate environment. So it's kind of like that third place, or that third teacher that we talk about. And how the classroom is structured can have a great impact on both the instructional practices of the teacher and the learning experiences of the students. So, and we mean more than just the setup of desks. We also want to include how displays are crafted and used, because they're more than just pictures, but we want any display to support learning and instruction, and the availability of resources such as manipulatives and whatnot. It plays a significant role in the literate environment. So one of these things that I want you to think about, and it supports problem solving, is a question board. While we often think of student work samples as samples of completed solutions, it's important to recognize the role of questioning in student thinking. Having students question is an important part of the development of students' mathematical thinking, and it's reflective of student work. With this in mind, a student work display could take the form of a question board. Students would have the opportunity to post questions related to a strategy, to the lesson goal, to a concept, or to a stumbling block that they would like to share with the class for the purpose of moving their thinking forward. And here is an example just of a question board that I've used. Part of the whiteboard, and you see that students would put questions on a Post-it note, and they would just put it up there on the board. And what that would become is that's a place for me to kind of look through some of the questions, and that helps shape what my instruction is going to be and the experience I'm going to give students. Now, I will kind of add a preface. Initially, I would put some of my own questions on this board as a way to kind of generate this, because I firmly believe we need students' questions to be the ones driving the mathematical learning. And then over time, students would feel comfortable in putting questions up, and they wouldn't put their name on them. They would just put anonymous questions up. And the cool thing was, initially, I would be the one responding to the questions and using these questions to address learning goals and opportunities for students. But over time, if students saw the value in this, they would come up and they would say, can I answer that question? Because I had the same question and I worked through it. So they became part of the discourse, and they became part of the responding to that. And I would have a few times a student would come up and remove a question saying, well, then that was my question from 2 days ago, but I now know what the answer is. Because if we want students to be self-questioning, we need to support students in generating questions and seeing the value of these questions. So I really want you to think about, and we can do this in a face-to-face environment, and we can also do this in an online environment that includes blended learning as well. I've seen people using Jamboard to do a question board for their group. I've seen people using Google Doc. I've seen people using Google Sheets, just as a way to kind of have a place for questions. Because if we're going to value students as questionnaires, then we need to have a spot that we want to kind of have that visible in the classroom and to work from that. Once again, these were the 3 spaces: the instructional, thinking, and physical space. And I want to highlight this. Where these intersect, where we consider all of these 3 spaces, this is where the learning happens, and this is where we have sustainable increases in student achievement and in professional learning for teachers. All of this comes back from, these are just a small snippet of the strategies within my book, and I spend a lot of time talking about problem solving. And if you want information on the book, you can send me a tweet or an email. Like Melina said, it's on your book contact list. And I know that what I've been doing is I've been supporting teachers using like book studies and like online book studies as a way to pull strategies out from the book, but to apply it to the concepts that the schools would really like to hone in on as part of their school plan. Or you can email me. This is my contact info. This is my email, dacostello@edu.pe.ca, and this is my Twitter. And if there's anything I can do, please don't hesitate to ask or to reach out. And I think that's it.